Hello everyone. Today we are going to solve problem 2095 from LeetCode, delete the middle node of a linked list. So basically, we are given a linked list and we have to delete the middle node. Now you're probably thinking, well, if it's even, which one is the middle node? If it's even, we're simply going to delete the one that is to the right of the halfway point. So mathematically, we can say, well, if they're indices 0, 1, 2, and 3, and the number of nodes is 4, if we divide 4 by 2 and take the floor of that, we get 2. So the node we have to delete is at index 2, or this one right here. So let's say if we're only given one node, which one should we delete? Well, we just delete the entire list. So that's an edge case. Okay, now the question here is, how do we get to the middle of the linked list? Well, actually, there's already an algorithm. It's called the tortoise and hare algorithm, and I'm going to try my best to explain the intuition behind it. So instead of thinking of it as a linked list, let's think of it as a number line, right? So let's say this is you, right? You're probably an average runner compared to someone like Usain Bolt. So let's say this is Usain Bolt. The bottom one is Usain Bolt and the top is you. So the idea of the algorithm is, when to get to the middle, we're going to have a fast pointer or someone who can go 2 times as fast as you. Well, why is this? Because let's say for every 1 step you take, Usain Bolt is going to take 2 steps because he's faster than you. So he takes 2 steps. Let's say he takes 2 steps, 1 step, 2 steps. For every 1 step that you take 1 and he takes 2. Again, he's going to take 2, 1, 2. And you're going to take 1. And finally, again, he's going to take 1, 2. He's going to be at the end, and you're going to take 1. Now notice what happened here. When Usain Bolt, who takes double the amount of steps you do, he will get to the end. When he's at the end, you're going to be at the halfway point. Because why? Because he took 2 times the amount of steps you did. We can also apply the logic. If he were to take 3 times as many steps, where would you end up? Well, if we think about it, if he took 3 steps for every 1 step you took, when he gets to the end, you're not going to be at the halfway point, but you're going to be at a third of the entire line. Okay, so now that we understand the algorithm a little bit, let's run it through an example. Okay, so let's say this is our list and we have a slow pointer which is going to point here, and our fast pointer is also going to start at the head of the list, but we also need a previous pointer so that once our slow gets to the middle, like let's say our slow eventually reaches here, we need a previous, the one before, so that we can access this guy's link, break it, and change it. So that's why we need our previous pointer to point to the one directly before slow. So the first part of the algorithm involves updating previous. We're going to update previous to point to slow, or I guess we could draw it here. Let's draw it this way. We're going to update previous to point to slow, which points to 1. Then we're going to move slow 1 time. That's going to be us taking the 1 step. And fast is going to be the Usain Bolt taking 2 steps. So it's going to go 1, fast, dot next. So it's going to go 2 times. And then again, fast is still not pointing to a null node. So we repeat the step. We update previous to slow. We move slow 1 time. And we move fast 2 times. So it's going to go here and here. So once fast now points to nothing or null, we know that for a fact slow will be at the halfway point, and previous is going to be the one pointing before it. So what we have to do is assign previous.next, or in other words, break this link and assign it to slows.next. So slow.next. And what that's going to do is it's going to reassign the previous next to slows next over here. And let's code it up. So the first edge case was if we were given a list with the only node. So if head.next is null, or in Python we can specify it like that. If we're only given one node, we return an empty list. And then we need our 3 pointers. So our previous, remember at the beginning, it's going to point to nothing because it's right before us. And we're starting at head. So slow, that's going to be us. It takes one step at a time. It's going to start at head. Fast is also going to start at head. And then remember, while fast still points to something, and its next also points to something, we update the previous. So the one before us we're going to update it to become us. Then we are going to take one step to the right, and then fast is going to take 2 steps. Remember? So this is like Usain Bolt taking 2 steps. This is us taking 1 step, and this is our previous updating. So then once this condition breaks, or once this loop finishes, our slow is going to be at the halfway point, and our previous is going to be pointing to the one before us. So what we need to do is simply this. We need to update the previous next, like I did in the drawing, and update it to slows.next. And after we've done that, that's everything. That's the whole solution. So if we run this, make sure it has no errors, and as you can see, it does work. Okay, well, that's gonna be it for this video. If you enjoyed or learned something, please leave a like, subscribe, share with anyone who might not know the intuition behind this algorithm yet, and I'll see you in the next video. Thank you for watching.